The third principal way in which we can determine if an object is moving is via a quantity known as an acceleration. The idea behind this is fairly similar to velocity. When we talked about velocity, we looked at there being a displacement occurring over a period of time, or a change in position occurring over a period in time. An acceleration is simply noticing that the object experiences a change in velocity over time. So if you take a look at this object here, we'll start it off in the center. Right now, its velocity is 0 because it's not going anywhere. If I start moving it to the left, it now has a velocity. Because there is a change in velocity here, this box can be said to undergo an acceleration. More specifically, its biggest period of acceleration is right when it starts moving, because that's where its velocity is changing the most significantly. Keep in mind, though, that this is a change in velocity, so it's possible for my object to be moving and for it to change direction. As direction is part of the vector velocity, any changes in direction will also have an acceleration. Now, one of the things or problematic things for this particular course involving acceleration is properly applying it requires knowledge of calculus. If you're following along with the written notes, as you should be for this class, there's quite a lengthy discussion in this section about calculus and what it means. The long and short of it is, if you're not familiar with calculus notation, or if that's a course you haven't taken, uh, you have to be very, very careful with the equations that you're going to use to solve problems involving acceleration. Because when you're dealing with a field like calculus, which deals with very, very small changes, you often run into problems in which there are constants of integration, which are random numbers being arbitrarily introduced into the things that you're dealing with. With that being said, the main takeaway is for every problem you have involving an acceleration, I strongly recommend that you only use two equations. These two equations, which you'll see on the center of your screen, basically say that final velocity is equal to initial velocity plus acceleration times time, and underneath it, displacement is equal to initial velocity multiplied by the change in time plus 1/2 the acceleration times the change in time squared. The 1/2 there is a constant of integration. It has no dimensions, but solely comes from the fact that we're calculating areas under curves. Now, with that being said, there are other equations that you may encounter in your textbook or online or somewhere else. What I will warn you, and this is a very, very big warning, is be very careful with them. There are several equations that you may be presented with in online sources that actually only work under a very limited number of circumstances. There's one very popular one that uses final velocity squared, initial velocity squared, acceleration, and displacement. It doesn't always work. In fact, it's pretty limited to working if you are only going in a single dimension. All right, so make sure that you're very, very careful with when you choose. These two, though, are safe. They will solve every problem that you will encounter in this course without any deviation or any special conditions. What's important to note that in these equations is that the velocities, accelerations, and displacements are all vectors, and thus they require use of vector algebra. So what you're going to want to do for all these problems is you're going to want to put all of these vector quantities into Cartesian notation, because the x and y parts will be separate from one another. In addition, you'll notice that in the bottom equation that deals with displacement, there is a delta t squared term in there. This means that this bottom equation may require you to solve a quadratic equation, which is the whole reason why it is included in the preliminary material. If you're provided with displacement, initial velocity, and acceleration, you can solve for the change in time, and you need to be able to do that successfully.